Bitcoin hit $1 trillion market cap this year. This has inspired some Bitcoin operations to expand, especially in the wake of the recent government crackdown of miners in China.
The ban on mining in China has caused a mass exodus to the United States, to Russia, and to any other areas where mining facilities are available.
Welcome to Rockdale, Texas, America's new crypto mining hub.
This building that's directly behind me, inside of the buildings, we have this shelving that's 1,000 feet long, 20 feet tall, and there are just miner after miner after miner after miner.
We went inside North America's largest Bitcoin mine to understand how it works and its energy footprint.
What is a miner? It is a small computer. They call it an ASIC miner. It is made to solve problems, and when they solve that problem, it feeds into the Bitcoin network. When it feeds into the Bitcoin network, you receive a reward.
To help us understand crypto's reward system a little better, we spoke to blockchain expert Bettina Warburg.
That's what mining is. It's a process by which people are contributing computing power and earning a reward. Less expensive.
Typically, mining operations go where energy is cheap. Right now, Texas has some of the lowest kilowatt-hour prices in America. That's due in part to a deregulated energy market, which means several providers compete to snag big customers like Windstone.
So there's environments like Iceland, Russia, China, Canada. Areas like Iceland and Canada have a cooler environment. There's probably less dust.
The puzzle, and putting as much computational energy into that challenge as possible increases your ability to actually win. It's intentionally inefficient.
Each building is 100 megawatts. For each 100 megawatt building, you can fit 30,000 new ASIC miners in it. In a Bitcoin mine, the consumption is basically taken by the miners. Each miner has about 3,000 watts that it's pulling.
Flowing through, enough to power 150,000 Texas homes during peak demand. That's a lot of juice. How do they manage to keep all those miners cool?
Our ideal goal is to keep the ambient temperature around 81 degrees. There's a lake about a mile from here. And so underground, we have a 8X line with a 1,000 GPM pump where we pump literally the water through this mile-long pipe into the facility, and it actually goes into holding tanks that then recirculate the water, and it pumps it back into these evaporative cooling walls that are 12 feet tall. Water is actually dripping down the wall of that evaporative cooling cell, and then as the air comes through it, it actually cools from 16 to 20 degrees difference between the front of the wall and the inside of the wall. The miners have fans, they have intake fans, and there's thousands of those fans running, and they actually suck the ambient air through the miner, and then there's an exhaust fan that actually pushes the air through the chips and into the heat aisle. As it goes through the miner, it then heats up because the chips, it's a processing, so it gets really hot, and then we capture the heat on the inside of the heat wall, and then it is evacuated out of the building through a quote-unquote chimney-like environment.
Inside the heat aisle, it literally feels like an oven. One Whetstone employee estimates that it can get as hot as 140 degrees Fahrenheit here.
So the S9 has a hash rate of 13.5 terahash. The new S19s are 110 terahash.
Hash rate measures how many computations a miner can do, usually in a second. So how much money can each miner potentially make each day?
Currently, a S19 with 110 terahash, the profitability every day for one machine is 30 USD.
Okay, so $30 times 30,000 miners times 2 big buildings, nearly $2 million a day for a facility this size.
We have a full staff of 120 employees. We work 24 hours a day, 3 shifts.
There are definitely some increased efficiencies on the horizon, such as faster processing chips for the miners, cooling them in immersion technology, but at approximately 73 terawatt hours annually, Bitcoin's energy consumption is more than the energy it takes to run every single television set in America.
I think ultimately the energy consumption question is